These are the notes for section 4.2, where we talk about adding, subtracting, and applying scalar multiplication to matrices. These three operations are basic techniques that we use to work with matrices. And because any matrix that we get in class is probably going to represent something, it's probably going to have numerical entries. So that means we can perform these sets of three operations on most of the matrices that we see. And when you add or subtract, you're going to add and subtract corresponding entries. So if you have two matrices, you're going to add the A sub 1, 1 entry plus the B sub 1, 1 entry. And they all have to match up. So you can only add 2 by 2 matrices to other 2 by 2 matrices, and you can only add 2 by 3 matrices to other 2 by 3 matrices. And its addition and subtraction, because they're really the same thing, is commutative and also associative. So the following are true. So our commutative means that A plus B is equal to B plus A. Order doesn't matter with addition. And associative, which is A plus B plus C is equal to A plus B plus C. But the order doesn't matter. So I could add A and B first over here, and B and C second, or first over there, and you'll get the same answer due to the properties of commutative and associative. So let's practice doing these things. So this is addition. So all you have to do is add each entry. So for the first one, it's 1 plus 2. And then the second entry is going to be 2 plus negative 5. And then the third entry is going to be 3 plus 6. And then you do 4 plus negative 8 for your fourth entry, 5 plus 1 for your fifth, and 6 plus 4 for your sixth entry. And this is just 3, negative 3, 9, negative 4, 6, and 10. Works the same way with subtraction. You don't really need to do anything different except you're subtracting this time instead of adding. And note that these are both 2 by 3 matrices. So for my first entry, it's 5 minus negative 7. Second entry is going to be negative 2 minus negative 1. Third entry is 0 minus 3, 1 minus 1, negative 3 minus 2, and 9 minus negative 4. Put all this together, and we get 12, negative 1 plus negative 1 is going to be negative 1, negative 3, 0, negative 5, and 13. This is our matrix there. So we can make these more complicated by multiplying by a scalar. So a scalar is like a constant multiplier. It's nothing really crazy or anything like that. So if you're multiplying by 3, it just really means you're adding the number to itself 3 times. And multiplying the matrix by 3 means the same thing. You add the matrix to itself 3 times, or simply multiply each element by that constant. So it's kind of distribute-y a little bit. It goes into each element, but it's not the distributive property, so you have to be really careful with it. But scalar multiplication has the following properties. So it has left and right distributivity, which means that if I have something like this, C plus D times M, it's going to be equal to the matrix M times C plus D, which is equal to the matrix M times C plus the matrix M times D. Keep in mind that C and D are the scalars in this little bit of property writing here. So let's write that down. C and D are scalars. Make that an actual S. As you guys can see, even though I'm filming, I still make mistakes. Associativity property is going to be that C times D times M is equal to C times the quantity D times M. The identity property just means that you can multiply a matrix by a scalar of a certain type and you get the same thing. That scalar is 1, so 1m is equal to m. Null matrix means that you can make it 0, so 0 times m is equal to 0. And then the additive inverse is if you do negative 1 times m, you're going to get negative m. So let's go through and try this out real quick. So to perform this indicated operation, you're just going to multiply each entry by 7. So 7 times 1, 7 times 3, parenthesis there, 7 times 5, and 7 times negative 4. This is going to give me the matrix 7, 21, 35, negative 28. Which is pretty easy. Now these can get really complicated because we can put it all together. So what I recommend in these is that you kind of do them separately. So you do 3 times 2, negative 1 times 2, 0 times 2, 4 times 2 first, giving you 6, negative 2, 0, 8 as your first matrix after removing the scalar. And then I got negative 3. You have an option here. You can either distribute the negative into it and change it to plus, or leave it the negative on the outside and just put the 3 inside. I'm going to distribute the negative in to make it plus. So this becomes positive 3, negative 6, negative 6, positive 3. And then I'm just going to add these two things together. So I get 9, negative 8, negative 6, and 11. So those are the notes. Make sure you do the practice problems. These ones should be a little bit more entertaining. You might want a scrap sheet of paper to help you out.